first. Let's see how it yeah, let's just see how it looks. Let's see if it zooms any larger on the machine. Yeah.
It's too small. That focus. Looks good.
Excellent. We'll get started in about 1 minute. Next meeting. What you need? Yeah. I'm not sure what it's doing.
Probably not.
I can't find it yet, but
Oh, well.
we'll do it. Okay. Let's get started. My name is Andy Malice, and my co-chair is Stuart Bryant. Unfortunately, Stuart was not able to make it to this meeting. So assisting me up here is our working group secretary, Dave Sinecrope. And Dave is usually the person who takes minutes, but seeing as Dave was up here helping to run the meeting, Himanshu Shah was very nice to volunteer to take the minutes. Thank you very much, Himanshu. And let's go on to slide 2. So this is the note well. You should have probably seen this by now, and I'll give you a moment to take a look at it. It's also available on the IETF website. This is the existing note well. This is not yet the new note well that's been under discussion. Next. Okay, this is our agenda for today. We're going to be starting with what we're doing right now. And then we're going to be going into layer 2 VPLS Yang model, which is Work that is primarily being done in the BEST working group. However, we're being apprised of it here because there are aspects of the work that touch on VPLS and other LDP-related work as well. Next, we're doing point to multi-point pseudowires, signaling using LDP. This is work that's being revived, and I'd like to thank Sammy and his team of co-authors for reviving this work, and we'll be talking more about that. Next, also LSP ping extensions for point to multi-point pseudowires. And finally, point to MPLS-TP pseudowire dual homing protection. Does anyone want to make any last-minute additions to the agenda? Seeing none, let's move on. Okay, so this is our working group status. We've been extremely productive. We've had 6 new RFCs since the last IETF. 7708, 27, 7769, 71, 95, and 96. This represents a whole lot of work for a lot of people, not just the RFC editor. I would very much like to thank Deborah for all the work that she's given us getting these drafts through the IESG, and also I'd like to thank the document shepherds for the work they do on reviewing the drafts and reporting up to the IESG, and of course to the authors themselves for making last-minute changes to the documents, to responding to the RFC editor for Auth 48 and so on. At the moment, we've completely cleared out the RFC editor's queue. However, I don't expect that situation to last long, because if you see on the next slide, we currently have 4 more drafts in the IESG. IETF PALS congestion considerations. We are currently waiting on the authors for a revised draft for that one. RFC 4447 BIS, the authors need to respond to some review comments. So I don't see either of them in the room, but they know who they are and they know what they need to do. There's seamless VCCD 02. Now this says in IETF last call, actually at about 4 a.m. this morning that changed. It came out of IETF last call, and there was an email about it overnight, and so now it's back in the hands of the IESG. And finally, PALS MPLS-TP pseudowire over bidirectional LSP, that is awaiting action from Deborah. Okay, next. We have one draft that's completed working group last call, but not yet gone to the IESG. We are waiting for document shepherd action on that one, and that's Matthew. Unfortunately, Matthew wasn't able to be here, so I can't berate him in person. But again, he knows what he's supposed to be doing. Next, we have one draft and working group last call. This has been an extended working group last call because it actually never completed. We did receive a good set of comments. We are currently awaiting a revised draft from the authors, and we expect a good number of revisions, so we'll most probably have a second working group last call on that draft. And finally, for other drafts that we have in progress as working group drafts, there's dual homing protection and coordination. We'll be discussing those on today's agenda. There's a point to multi-point pseudowire. Again, that's also on today's agenda. Then we have just 3 other working group drafts that are currently in progress. MC PON, status reduction, and VPLS PIM snooping. And so that's it for the chair slides. Any comments or questions at this point before we move on to the rest of the agenda? In which case, thank you all. Let's move on to our first agenda item, which is Patrice.
It's not like I stay in the box. All right, my name is Patrice from Cisco. I'm here to present again all of those Yang model Today I will just cover the L2VPN. I think that's what is relevant for this work group. Okay, so we can switch. Next. Okay, so this is the third time already that we are presenting what we are doing in Yang with all the bunch of voters. I think that we have for this draft. So it started about a year ago. So it's the third version I think that we are presenting. Where we are right now, I think that's the purpose of this presentation, is to give you a quick update. I think the stage that we are at is we are trying to really polish our config model. I think we went into very greedy detail about the whole configuration. And I think we are very close to be done, and few action has been coming out of that. So for the people who has been following the draft, we'll see few differences on the containers and how the hierarchy has been designed or lined up, I guess. And also there was some worry, I think from my side, about the everything which is related to the interface. I know there's a lot of work happening with IEEE on Yang interface definition, and honestly, we don't want to play the game, or we don't want to interfere with what these guys are doing. So we just took a step back, and we are leveraging, I think we take out everything which may get confusion there out of the model. So we get IETF alone, and we don't we don't need to be playing a game with IEEE folks. The two last thing we made also is we bring EVPN to the model as a reference, because what we are what the L2VPN Yang model is defining really is kind of the L2 service, like for bridge domain and point-to-point. And EVPN also is one of those instances that can use or can leverage a bridge domain or a point-to-point connection. So that has been added. And finally, we brought also the Opera data. So everything that wasn't there before, I think before we can move on the next forward group adoption for that work, I think that was missing. And this has been introduced as well. Next slide. So yeah, so anyway, for people who is not aware about what we are doing, it's been authored, I think, by 20 people or 25 people. So I guess a lot of company has been helping and participating to that work, which is great. And again, we would like to have the work group adoption with best not here. So, but just to let you know, this is our next step. Okay. All right. Question? You cannot have a comment on your draft, man.
Himanshu Shah from Siena. I just wanted to mention that about that interface draft that we are pursuing here in IETF, and there is a corresponding work going on in IEEE that Patrice mentioned. I think we have we have hit a snag there, and you know about that, Patrice, right? Mm-hmm. I think the license statement from IEEE is blocking the interface draft. Mm-hmm. The issue is with the VLAN, and I had a very brief chat with
Robert?
I forget his name. Sorry?
The Robert Wilton for the interface?
No, I don't know if he's here or not. He's from IEEE 8021 committee. Yes, Glenn Parson. Glenn Parson, yes.
That's good. You just stopped my comment, which was go talk to Glenn Parson.
Yeah.
There should be, I think he's one of the liaison.
Yeah, he sent some letters. I think we are trying to hold a meeting with him, and we were not able to before this meeting. So we thought maybe we can meet him during this meeting. And I don't know whether they officially, everybody officially met or not, but I saw him in the hallway and I asked him about, and he said, well, the attachment circuit, the VLAN, that's a forwarding construct. And I'm not going to allow, and that's not you shouldn't be doing that.
Which is fine. That's exactly our position, right?
But there is an overlap on, attachment circuit is part of the, is the interface.
Yeah, which is not this Yang. I think the problem is will be more with the interface Yang that
Right. So,
IETF is proposing.
so yeah, we want to reference the interface IETF draft. Interface draft is blocked on the VLAN and the liaison and all that thing. So I don't know how that gonna resolve. That's all. That's the update I wanted to give.
But this is kind of orthogonal to what we're doing because we are leveraging that work.
Mhm.
Say that again, you have many.
Now, what I was saying is what we are doing for L2VPN here is really kind of orthogonal. We are using those Yang interface, but we are not defining it. So if they are stuck, we are not stuck. We're just not using it.
It sounds like there needs to be a clarification.
Yes,
Who's
definitely.
got what role, where the dividing is.
For the interface, that's right. But for the L2VPN, yeah, it's pretty clear where we are.
Okay, good. Okay, thank you very much, Patrice.
Thanks.
And Himanshu for that update too.
Okay, one more.
Okay. Next, we have Sami, who's coming up to talk about point-to-multipoint pseudo-wire signaling using LDP.
Good afternoon. Yeah, is this
Why don't you
the,
go back first?
okay, yeah,
You can introduce it.
yeah,
That's
sure.
the first one.
Okay, my name is Sami Woutros. I'm presenting on behalf of the authors a point-to-multipoint solution draft. This draft, as Andy said, we revived the draft. The draft has been around for 5 years now. And actually, it was waiting initially on the requirement document to become an RFC. And it became an RFC 7334. So we decided to revive the draft and provide a solution. Solution here is for point-to-multipoint pseudo-wire using LDP signaling. We already have a solution, it's BGP signaling, but this one is the LDP signaling version of the point-to-multipoint pseudo-wire solution. Next slide. So yeah, so the draft, as we said here, is a solution for setting up point-to-multipoint pseudo-wire using LDP, with an option as well to have a point-to-point pseudo-wire back from the leaves to the root. So we have traffic that can go from the root over the point-to-multipoint tree to the leaves, but you have as well an optional unicast traffic coming back from the leaves if needed. The point-to-multipoint pseudo-wire can ride over a point-to-multipoint LSP signaled with MLDP or RSVPT. So the draft, in summary, introduces new facts and new as well TLVs and an LDP capability. Next slide. So this is the mandatory message that we have in the signaling. In that mandatory message, we specify the point-to-multipoint pseudo-wire FAC, which is new. We specify as well a new interface parameter sub-TLV, or TLV, sorry. Group ID TLV already exists. And as well, a label TLV. This is, if we are not doing inclusive, we are doing aggregate inclusive or selective, then we need an upstream assigned label for the point-to-multipoint pseudo-wire if it's sharing the same point-to-multipoint signaled LSP. Next slide. This is an optional message, and in here, the root can specify to the leaf a point-to-point LSP label that the leaf can use to send unicast traffic back to the root. Next slide. Yeah, actually, this is this TLV or sub-TLV here is included in the interface parameter, and this is where we are specifying selective trees. So as shown here, we are showing the group, the S, comma G group of a given multicast group that can be included over that point to multi-point pseudo-R, and this is when we support selective trees, right? Next slide. This is the LDP capability that we are introducing. So LDP capability is a new mechanism that has been in place. So we simply define a new LDP capability for this point to multi-point pseudo-R signaling. Next slide. Next slide. Yeah, it was duplicate.
No, it was my Mac being delayed.
No, actually, that's not this one. So this is a wildcard FEC as well. Wildcard FEC allow an LSR to do some wildcard operation like mass withdraw, for example, for a given FEC. And we are defining here as well, or extending the wildcard pseudo-R signaling FEC to allow as well for point to multi-point pseudo-R FEC to be treated similar to the point to point pseudo-R that we support today with FEC 128 and 129. So here we extended the type wildcard FEC specified for those point to point pseudo-R to include that PIMC tunnel type. So we can specify here what set of point to multi-point pseudo-R we can, let's say, withdraw for a given underlay, given PIMC tunnel type underlay. Okay. Next slide.
Use the arrow key. Working. No, the arrow key.
Okay, so this is the summary here of what we need to allocate from IANA. So we are defining new FEC 130 and 131 for point to multi-point pseudo-R, and for as well the point-to-point downstream FEC element that the root can signal as well to the leaf to allow the leaf to send some traffic back for that pseudo-R. We as well need from the LDP TLV namespace a new type for the point to multi-point pseudo-R capability. And given that we are going to be as well riding that point to point pseudo-R, especially for the inclusive case over MLDP, so we want to define a new opaque value element type, because if it's an inclusive MLDP LSP, it's going to be carrying layer 2 traffic, and we need to know that this signal point-to-point MLDP LSP is going to be carrying layer 2. So this is why we need that new opaque value type. And finally is selective tree interface parameter sub TLV, and the extension to the wildcard with the PIMC tunnel type value in the wildcard already defined for the point-to-point pseudo-Rs. Okay. So that's about it. So I think, yeah, the draft has been around for 5 years, as mentioned, and it is the solution for the requirement draft that became an RFC. So we're waiting for the draft. We think that it's probably ready even for last call.
Yes, and in fact, if you could send a formal working group last call request to the list, we will take it from there.
Sure, thanks, Andy.
Okay, great.
Okay. So I'm on the next one.
Okay, and next, Sammy's staying up. He's now talking about LSP ping extensions for point-to-point, multi-point pseudo-wires.
Yeah. Okay. Yeah. This draft as well has been around for a while. It has been ping-ponged between BES and PALs, I guess, for a while too. So because what's defined here can apply as well for BGP signal point-to-multipoint pseudo-R. Next slide. So no, sorry. So yeah, it can apply for point-to-multipoint pseudo-R that could be signaled by LDP or by BGP. It's defining a new target FEC stack element for LSP ping for point-to-multipoint pseudo-R, and as well specify operation for both inclusive and aggregate inclusive and selective point-to-multipoint pseudo-R. And with support for underlay point-to-multipoint LSPs with MLDP or RSVPT signaling. So it's simply a new definition for a target fact stack element. So next slide. So this is fact stack element. We specify in it the AGI or that identify the VPLS instance per se, and as well the root or the originating IP address or the SI, the source address identifier that can specifies the root of the point-to-multipoint pseudo-R. And yeah, we are requesting, of course, to assign for that sub TLV from the registry. I think we didn't do the request yet, but we can ask. I don't remember. Sorry. Yeah. Next slide. So yeah, the slide as well is talking about how can we leverage the control for the echo response as specified in 6425 to prevent congestion when all the leaves are sending the echo reply back, as well as defining the same RFC, a way of limiting the number of responses coming back by specifying in the request itself using the responder identifier TLV which leaf should respond to that echo request. Yeah, the draft proposed using GAL and GASH or GAL and ACH associated channel to encap the packets sent over the point-to-multipoint tree here for the pseudo-R to encapsulate the LSP ping echo request. So in terms of operation, given that we are going to encapsulate with the GAL and the ACH, for inclusive tree, we send over the point-to-multipoint LSP. For aggregate inclusive, we need the upstream label, so we have to encap the packet with the upstream label before we put the GAL and the ACH as well. The idea here is that, of course, the P routers will only do the swap operation, but or the replication, sorry, over the P3. But the bud and tails will be the one who are going to decapsulate the packet and respond to the echo request. And here we are specifying that the response can come back over as well the point-to-point pseudo-R that's signaled in the point-to-multipoint LSP. I think that's in the next slide. Yeah. So, yeah, go ahead. Go back.
So, Lou Anderson, I just make you aware of that we're doing a 4379 bis. So, could you coordinate with the authors if there are any changes in this area?
Sure,
Yeah.
sure. So there is a base for 4379. Okay. Sure, yeah. So next slide. So for, yeah, here it's simply saying if the root want to get the echo responses, echo replies back over the point-to-point LSP from the lead back to the root, then it can use, set the reply mode to 4, which is reply via application level control channel, right? So, and I think, yeah, that's about it, right? So.
Now, one thing I would like to be clear on, when you say on your slide, looking for working group adoption, go back there. Based on the name of the draft, you're looking for BESS, working group adoption at this point?
Yeah, actually, Parag put it for BESS, right? But when he refreshed it, right? So because it applies for, it can apply for BESS as well, but even though the terminology here is talking about AGI and SI and so on, right?
Yes.
So, which is again LDP.
LDP, yeah.
So we are planning to refresh it with PALS, but he couldn't refresh it with PALS because it was after the deadline, right?
Okay, very good. Yeah, so refresh it with PALS and then ask for working group adoption.
Okay, sure, and we'll address as well comment from Loa
Yes.
about
absolutely, yeah.
40, okay.
Great.
Thank you very much. Any question, folks?
Himanshu from Sienna. So this point to multi-point thing works for multi-segment pseudowire as well, right? And the previous one. And
No,
the-
point to multi-point, multi-segment pseudo-wire, no, I don't think we defined point to multi-point, multi-segment. There was no,
That wasn't the requirement, you're saying?
No,
it was not, I don't think it was in scope for this draft.
Mhm.
So I'm not sure if we put explicit whether it's out of scope or not, but we can check on that, but it was not in scope.
Okay. And this VCCV ping also does the trace route or just the ping?
It's defining only a target fact stack element. I think we define the ping and imply the trace, but the trace route won't apply here because it's only one segment that we are pinging. But
I mean, is it from a specific route to a specific leaf?
it's one segment from the point to multi-point pseudo-wire
Yeah.
perspective, right? But if you are riding over a point-to-point LSP, then you can do as well, multi-point LSP, sorry, you can possibly do the trace route, right? On the point to multi-point LSP. It does leverage what's the point to multi-point LSP offered to. So because it's here, you are defining the delta on top of the procedures that has already been defined for the point to multi-point LSP.
Sorry, I didn't. So you're saying we already have point to multi-point pseudo-wire ping and you're extending
No,
that?
we
or-
already have point to multi-point LSP. ping.
LSPs, okay, so you're extending that for
This is the
pseudo-wire.
extension for point to multi-point pseudo-wire
Yeah.
that's riding over the point to multi-point LSP.
Okay, so I don't know 100% whether we have a trace route for LSP or not, but
For
if
point
there
to
is one,
multi-point,
yeah,
point to multi-point LSP, you mean?
yeah,
I don't know.
okay. All right, we,
Trace route.
yes.
so you need anything for that?
I was saying for point to multi-point pseudo-wire, trace route will make sense when you do multi-segment because it's on top of point to multi-point LSP. This is the only comment I made.
Sorry. So George said that we have a point to multi-point LSP trace route.
Correct.
So do we need extension for, or any, are there any applicable extensions for point to multi-point pseudo-wire trace route?
If you have a logic.
The extension, exactly, when you have the multi-segment pseudo-wire, trace route will apply, but whatever exists for point to multi-point LSP can be leveraged by the point to multi-point pseudo-wire, that's what I was saying, but you have a new target fixed stack element that we are defining here that you need to put in the packet.
Okay.
You are right, like when multi-segment becoming scope, then you will have as well, whether it's gonna be the same fact along all the segment of the pseudo-wire, so we may have different facts and you may be signaling partial as well segment on the point to multi-point pseudo-wire, so that as well need to be defined. But the scope, as I mentioned, we were limited it to only one segment, one pseudo-wire segment. Sorry, go ahead.
It's Sharon, the Valley Broadcom. So just a question, do you only support GAL or do you support VCCP type 1, 2, and 3? Or at least 1 and 3?
We will, all the VCV
All of
type,
them.
yeah, will be supported.
Because you mentioned about GAL.
Actually, here we are not, when we say VCV type 4, we were talking about only the reply backing channel if it's needed because we have a point-to-point, we have an in-band reply. But that does not mean that we don't support the rest.
But you had you mentioned
We
you
are
have to do
following-
label swap. That's what you said. So whatever it is, it will remain there, right? You mentioned there's a label swap.
This is the top label, not
Yes.
the ping over the point-to-multipoint, right?
So if you swap the top label, then everything, whatever you had VCCP will remain the same, right?
Correct, because the pseudo R is one hop away. I'm not sure I
So I'm
get
saying
that.
if, for example, you have VCCP type 1,
Uh-huh.
your reply will be VCCP type 1. It cannot be VCCP type 4, for example.
Yeah, this is the out of band replies.
Oh,
yes.
okay. No, okay.
Correct, yeah.
Sammy, we also have a question from Jabber, from Stuart. Stuart asks, is there now a use case for multi-segment point-to-multipoint pseudowire? There was not one the last time we asked.
Was out of scope.
Oh, okay, so the answer is that it is out of scope.
For the solution draft, right?
Those are two different questions.
Yeah.
okay? One is there a use case? Yeah, those are two different questions, though, right? So it's out of scope for the document, but whether there's a use case or not is another question.
Yes.
Have you run into a use case?
I don't know.
I don't either.
No. Himanshu may have. Himanshu's coming back to the mic.
Yeah, I mean, multi-segment pseudowires are there and deployed,
Point to point.
point to point, yes.
But
So,
the thing's talking
I mean,
about
if you have-
multi-segment.
Yeah, I mean, once you start looking into point to multi-point, it obviously get applicable to the multi-segment pseudowire too. So if we are discussing about whether there is a use case or not, I would say yes.
Okay.
So,
Okay. Any other questions for Sammy before he sits down? Okay, thank you very much.
Thank you.
Okay, next we have Ji Dong, who is going to be talking to us about MPLS TP pseudowire dual homing protection and coordination. Two separate drafts in one presentation.
Yes. Okay. Hello, everyone. This is Jay presenting the update on the dual homing protection for MPLS TP pseudowires. Okay. Okay, a little recap about this dual homing protection mechanism. Basically, it is applicable to networks with dual homing PEs deployed on one side or both sides. And the benefits of this mechanism is it can achieve local protection, which means when there's a pseudowire failure, you can avoid AC switchover, and you can also avoid the pseudowire switchover due to the AC failure. Basically, this is achieved with DNI pseudowire deployed between the dual homing PEs. It can be used to carry the protection traffic, and also there's some coordination mechanism between these dual homing PEs for this protection and coordination. Next slide. Okay, here we have two drafts on this dual homing protection mechanism. One is dual homing protection. It is mainly about the framework and the typical scenarios of this mechanism. And another one is about the protocol extensions and the mechanism of the dual homing pseudowire protection. And both the framework and the protocol draft has been adopted in April last year. In the version 01, both drafts, we just have minor editorial changes to keep it alive. And next slide. Okay, in the recent update in the version 02, for the framework document, the co-authors reviewed this document, and we found that we can only add some editorial changes, which means this draft is already pretty stable. For the protocol document, we add some more descriptions. The first one is we generalize the use of the dual node switching TLV. So now it can be sent by either the protection PE or the working PE. And we also improve the specification about the protection procedures. And the third part is we did also some editorial changes to this draft. Okay, so for next step, we would like to collect feedbacks on the new revisions. And since both drafts are getting stable, we would like to move them towards the working group last call.
Okay, thanks. I'd like to ask, first of all, of course, does anyone have any questions? based on the presentation. Any questions or comments? Secondly, I'd just like a show of hands. How many people have had a chance to read either or both of these documents? It's a good proportion of the room, so that's great. Thank you. So what I'd like you to do is, please, as it says, we're starting to get close towards working group last call. So I'd like to ask you all to give the draft another read and post any comments that you have to the list. And we'll give that a little bit of time to percolate, and then we can go from there towards working group last call for the two documents. With that, I'd like to just point out that Glenn walked in the room. Oh. We were talking about you, Glenn, earlier. So, anything else on this draft here? Okay, thanks.
Thank you.
And with that, we've reached the end of our agenda. So I'd like to thank you all, and well, sure.
You can try to put him on the spot. Why don't you why don't you explain, and then you can counter comment.
Hi, Glenn.
No, that one doesn't work. You have to use front.
So I mentioned about the IETF interface draft. We have a dependency on that, and I know that there is some communication between the IEEE and IETF. Can you expand on that?
Hi, I'm Glenn Parsons with Ericsson and also the chair of 802.1 and IEEE. So there was a coordination meeting this morning between IETF and 802. And so we discussed this morning and went over the issues and agreed a way forward to progress it. We'll discuss it on some conference calls like had been planned before to go over the issues. So that's because we wanted to have all the right people in the room because Robert is not here at this IETF, for example. And so so now it's to have them all in the virtual room on the conference call. So that's the plan for the way forward on that.
Is that an open call or just amongst?
Yes, it's an open call. So Dan Romoscano has so he tried to set one up for last week, for example, but a bunch of people weren't available. And so we deferred it to some other time. And so it's the same sort of thing.
What were the IEEE concerns? I think is what it's asking.
Well, I'm sorry, what would you like to? So we can go into more detail on these calls, yeah.
Okay, thank you very much, Glenn.
Okay, thanks.
Okay, great, thanks. So with that, I'd just like to say, see you all in Berlin. Thank you.
We still got time.
Yeah.